The birth of the first generation of children on a low-gravity world, whether the Moon 0.16 g or Mars 0.38 g, will be the definitive turning point where humanity transitions from temporary explorers to a truly multi-planetary species. However, removing the 1G evolutionary blueprint that has shaped terrestrial life for 4 billion years opens up a massive biological and anthropological Pandora's box. Phase 1. The invisible scaffold, gestation and birth. The complications begin long before a child is born. Human fetal development relies heavily on gravity as an environmental cue. Cellular disorientation. In a low-gravity environment, the fluid shifts inside a pregnant mother's body, alter hydrostatic pressure. This can confuse the chemical signaling pathways that dictate how a fetus's stem cells differentiate into specialized tissues, particularly cardiovascular and structural systems. The skeletal blueprint. On Earth, a mother's body actively leaches calcium from her bones to build the fetus's skeleton, a process tightly regulated by gravity-induced mechanical stress. In low gravity, a mother's bone density drops drastically. Managing this maternal calcium crisis while trying to calcify a developing fetal skeleton will require intense, specialized medical intervention. The mechanics of labor. Natural childbirth relies heavily on core and uterine muscular strength, which degrades significantly in partial gravity. Furthermore, if a mother's pelvis suffers severe bone density loss during the pregnancy, the structural integrity required for natural delivery might be compromised, making planned C-sections the baseline standard for extraterrestrial births. Phase 2. Growing up. Tall and soft. Children born on the Moon or Mars will look, move, and grow entirely differently than children on Earth. They will be the first true Homo spacium. The elongation effect. Without the constant downward compression of Earth's gravity, the intervertebral discs in the spine will expand fully. Children born in low gravity will grow significantly taller and leaner than their terrestrial cousins, sporting long, slender limbs. Muscular and cardiovascular atrophy. Because the heart won't have to work hard to pump blood upward against Earth's gravity, the heart muscle will naturally downsize, reshaping into a more spherical, less muscular organ. Skeletal muscles, especially the calves and thighs, will develop far less mass because moving around requires a fraction of the effort. Vestibular divergence. The inner ear's otoliths, the tiny stones that shift to tell your brain which way is down, will adapt to a new baseline. A Martian-born child's brain will map balance and spatial awareness perfectly to 0.38 g. Phase 3. The one-way cosmic divide. The most profound consequence of this generation's birth is that it creates a permanent biological segregation between Earth and its colonies. The 1G trap. For a child born and raised to adulthood in Martian or lunar gravity, Earth will be a hostile, environmental death trap. If a 20-year-old Martian-born human, built with a smaller heart, thinner bones, and elongated stature, tries to visit Earth, the sudden imposition of 1G would feel like a crushing weight. Their heart would struggle intensely to pump blood to their brain, likely causing immediate chronic fainting. Their underdeveloped bones would face severe risk of stress fractures just from walking, and their vestibular system would experience catastrophic, debilitating motion sickness. For the first generation of spaceborne children, Earth will not be a home they can return to. It will be a high-gravity wonderland they can only ever observe through screens. Phase 4. A brand new culture. Growing up inside pressurized domes or subterranean lava tubes under a weak gravitational pull, will forge an entirely unique human psychology. Three-dimensional agility. Children raised in low gravity will view architectural space differently. Instead of walking along two-dimensional floors, they will utilize walls and ceilings, mastering a hybrid style of movement that blends light acrobatics, bouncing, and swimming through air. The outward anxiety. Having never known an open blue sky or an unshielded horizon, the first generation might view the vast, unprotected spaces of Earth with a deep, instinctual agoraphobia. Safety to them will mean the comforting, rigid geometry of structural bulkheads and airlocks. What's your perspective on this? Do you think humanity should rely entirely on artificial gravity rotation ships to raise children in a healthy 1G environment? Or should we embrace the low-gravity mutations as the natural next step of human evolution?